Hey everyone, welcome to the lab demonstration for Lab 5 of CSE 4308. So let's take a look at the topics that we will be covering in this demonstration. We will be taking a look at ER models. We will take a look at an example scenario, which will help us understand an ER model more properly. Then we will try and understand what relationships between entities mean and how they can be represented by using ER diagrams and by using some other different kinds of notations. So let's get right to it. So I'm pretty sure you guys have already studied about ER models in your theory class, but just to give you guys a refresher, let's say as a database designer or as a software designer, whenever you actually go to a client, the client will give you a very high level description or a high level example scenario of what the client wants. So let's say as a developer or as a database designer, you went to the manager of some institute, and that manager simply told you that he wants an application that can manage his employees, and his employees are basically instructors, and also his institute will offer some courses, and these courses will be conducted by the said instructors. Now the instructors will have different kinds of information like name, then his age, phone number, and so on. And similarly, the courses will have their own attributes like the course ID, course credit, and so on. So that is the only description that you're going to get from your client, that is from the manager of that institute. Now, as a database designer, it is your responsibility to actually take that information and convert it into something that you can use to actually develop a proper application. Now, when developing an application, rather than using a vague description like this, it is always better to use a diagrammatic view of the description that you have just received from the client, and then use that representation to actually create your application, right? So that diagrammatic representation that we just talked about is what is known as an ER model. All right, so let's try and understand ER models in a bit more detail, or an entity relationship model, that is. So let's say this is me. Okay, I am an instructor and I have some properties. So one of my properties is name, and my name is, let's say, Anas. Then my age is, let's say, 50. My phone number is, let's say, 0123. So I am an individual who has three properties like name, age, and phone number, and these properties explain me or describe me as a person, right? Similarly, there can be another instructor, and let's say his name is XYZ. His age is 55, and his phone number is 1234. Now notice that he also has the same set of attributes, but the properties of those attributes describe him as another person, as another individual. So this instructor here, that is Anas, is not the same as this instructor here, which is XYZ, right? They are both individually different people, and these properties basically are what make these properties basically make them independent from one another. So we can say that this instructor here is an entity of his own, and this instructor here is an entity of his own, because he has some differentiating properties from the other instructor, right? So if I were to generalize the properties between these two, I can say that they have common properties like name, age, and phone number, right? And if I were to make a table of this information, then I would get something like this, right? I would have the three attributes or properties, name, age, phone, and I would have two entries, name Anas, age 50, phone 0123. Similarly, name XYZ, age 55, and phone number 1234. Right, so this is what we can get when we actually convert this information here into a table, right? So here we call this to be an entity set. So entity set is basically a generic representation of some entities in your database, okay? And these individual entries in your table are what we call entities, okay? So essentially, instances of entity sets are basically called entities, all right? Now, let's say that I have another entity or another basically, yeah, let's say we have another entity called course, okay? So let's say I have one course here. Let's just draw something like this. And let's say this course has information like course ID, which can be something like 4103, and credit, which can be something like 3. Similarly, I may have another independent course. This course will also have an ID of its own, let's say 4104, and its credit is going to be 2. So we can also say that these two courses that we just created are independent from one another because they have properties that describe themselves as individuals, right? So they can be differentiated from one another. And so if we were to create another table to represent this information, we would get something like this: a course table with 2 attributes or 2 properties, ID and credit, and we would have 4103, 4104, credit 3, and credit 2, right? So this is what we would get. So notice that here as well, we can call this course a generic representation as the entity set, which consists of the schema of that table, right? And the schema of the course table is basically the name of the table course and the columns that are present inside this table, which are basically ID and credit. So this is again an entity set, and this 2 entries are entities inside that entity set, right? Now, this is how you can basically convert a scenario that is a high-level description from any kind of scenario into a table, right? But these were some very simple examples. What if you were to get some very complex explanation or some more detailed explanation? In such cases, it would have been much easier if you actually got a graphical representation of this information, and then you would have been able to convert them to tables much more easily, right? So let's take a look at how this is going to look like if we were to convert this into tables, or sorry, not tables, into a diagrammatic view, which is known as the ER diagram. So let's talk about the description that we just discussed earlier. That is the description of the example scenario that we just discussed earlier. So the manager of that institute told us that he wants to store information related to instructors and courses, right? Now, whenever you actually get any kind of high-level description from anyone or a high-level scenario, then what you can do is highlight the major nouns that have been used by the client or by the scenario. So in this case, the major nouns that we came across were instructor and course, right? So from this, we get a good idea of the entities that we need to work with whenever we actually create an ER diagram. So the way we can represent an entity in an ER diagram is by something like this. Just simply draw a square, give a line here, write down the name of the entity at the top of the line, and there, this is an entity. Now, the manager, or the client in this case, also talked about some properties of that instructor, of the instructors that are in his institute, right? So they will have something like name, age, phone. Now, similarly, we will have another entity called course. So we will draw that in the same way we have drawn the instructor entity. There we go. All right, that's all good. Now, from his scenario, we not only got the information that we will have these 2 entities, but also got an idea of what the relationship is going to be between these two entities, right? So the manager said that, or the client said that there are going to be courses which are going to be conducted by the instructors, right? So we know that the relationship between instructor and course is something like this. An instructor is going to conduct some course, right? So this relationship can be depicted by using this this square again, or this diamond shape, if you want to call it that. And we can name the name of this, that is, we can give the name of this relationship as conduct. Okay, so let's just connect this diamond shape to these two entities like this to signify that the relationship conduct happens between instructor and course. Okay, all right. Now this is basically what is known as an ER diagram. This is not complete yet. I'm going to complete it a little bit later, but just for your understanding, this is what is known as an ER diagram. So an ER diagram is going to contain entities like this, and it is going to contain relationships. Now, obviously, this is a very simple ER diagram, so it contains only two entities and only one relationship. In a proper ER diagram, in a proper example scenario, you will get many more entities and many more relationships that happens between multiple entities, right? So we will take a look at those later in your lab tasks, but for now, this is what we are going to work with to understand the basic concepts more easily. Now, as I said, we will come back to this ER diagram later. For now, let's draw a set theory diagram and understand what is happening in our example scenario. Let's represent the instructors by using this semicircle here, and the course entity by this semicircle here. Okay, and let's also draw another semicircle here to designate the relationship between the between the instructors and the courses. So now, let's say in that specific institute, I may have multiple instructors, right? Let's say I have I1, I2, and I3, three instructors, right? And then in the course side, let me just rename this so that I don't forget what this is. And in the course side, I have course 1, course 2, course 3, and course 4, okay? And this is the relationship between the instructor and the course entities. Now, from general understanding, we can already guess that an instructor can take multiple courses, and each of the courses must be taken by at least one instructor, right? So if I were to connect these relationships, I can do something like this. So if the manager has already mentioned that instructor 1 takes courses 1 and 2, then I can do something like this, right? And at the same time, I can also do something like this. So this is basically showing that instructor 1 is conducting course 1 and course 2. Similarly, I can say that instructor 2, let's say, is responsible for conducting course 4, and instructor 3 is responsible for conducting course 3. All right. So according to this set theory description, we can easily understand the relationship that is happening between instructor and course, right? Now let's head back to the ER diagram again, and let's see how this can be translated into our ER model. All right. Now notice that we have mentioned something in that set theory diagram. So each course must be conducted by one instructor, right? So for example, in the figure or in the table that we had created earlier, we had two courses, right? 4103 and 4104. Now, obviously, one course must be taken by one instructor, right? So we can say that the course, any entity in the course table, that is any entry in the course table, must be connected at least to one instructor in the instructor table, right? So for that, we write 1 over here, all right? And then we can also say that the maximum number of instructors that a course can be connected to is also 1. because two people will not be taking the same course in the same class at the same time, right? And so we can say that the maximum number of instructors that one course can be connected to is also 1. All right. Now, these two numbers, that is this one and this one here, these two numbers that we just wrote are what is known as the minimum cardinality and maximum cardinality, respectively. The minimum cardinality is also known as the participation constraint, which is this one. Participation constraint. And the maximum cardinality is known as cardinality ratio constraint. Cardinality ratio constraint. So in case you have difficulty remembering those terms, just remember that the minimum one is known as minimum cardinality, and the maximum one is known as maximum cardinality. All right, so far so good. Now, we thought about this from the course's perspective, right? But what about the instructor's perspective? If we were to think about this from the instructor's perspective, let's see what would have happened. Now, as an instructor, since I am registered in that institute, I have to take at least one course, right? Otherwise, why am I even employed there? And so I can say that one instructor, that is each instructor from this instructor table, is definitely going to be connected to at least one course from the courses table, right? And so my minimum cardinality, that is the minimum cardinality of each instructor, is going to be 1, right? But what about the maximum cardinality? As an instructor, am I really limited to taking only one course? Of course not. I can obviously take many other courses as well, right? So in that case, I can say that the maximum number of courses that an instructor can be connected to from the courses table is many, right? So the maximum cardinality is going to be star, which basically signifies many. All right. So in this case, from the instructor's perspective, the minimum cardinality is 1 and the maximum cardinality is many. All right. And there you go. That's how you basically understand the cardinality between multiple entities in a relationship. Now, when asked what is the minimum and maximum cardinality of the instructor entity in the conduct relationship, you know what to answer, right? 1 is the minimum cardinality, and many is the maximum cardinality for instructor. However, when it comes to course, the minimum cardinality is 1, which is the same as instructor, but the maximum cardinality is also 1, which is different from instructor. All right. Now, it is not necessary that the minimum cardinality is always going to be 1. In some cases, the minimum cardinality can actually be 0 as well. So if I were to give an example for that, let's say in the same institute, the manager is also willing to hire some teaching assistants who will basically help the instructors take those courses. All right. Now, an instructor may or may not need any teaching assistant, right? So at first, let's actually draw an entity for the teaching assistants. And let's say he or she will have attributes like name, age, salary, and something else, maybe. Doesn't really matter. And the relationship between these two entities, that is instructor and teaching assistant, is something like this. The teaching assistant is going to help the instructor, right? So we can name this relationship as help. So let's just connect this two. And here, now let's think about the perspective from the perspective of the teaching assistant. Now, a teaching assistant is definitely going to help some kind of instructor. Otherwise, he would have not been employed in that institute, right? So since the teaching assistant must definitely be connected to at least one instructor, we can say that his minimum cardinality is always going to be 1, right? However, when it comes to the instructor, an instructor may or may not need any teaching assistant, right? So we can say that at any given point in time, an instructor may have 0 teaching assistants. So the minimum cardinality for instructor in this case is going to be 0, all right? Now, as for maximum cardinalities, an instructor should not need more than one teaching assistant if he even does need anyone, right? So we can say that the maximum cardinality for instructor in this relationship is 1. On the other hand, a teaching assistant may help multiple instructors simultaneously. In that case, we can say that the maximum cardinality for the teaching assistant is many, right? All right, so that should clear your confusion about minimum and maximum cardinalities. Now, another important thing to remember here is the kind of relationship or the participation type of the relationship of the entities in any kind of relationship. So let's take the example of the help relationship here. In this case, we can see that the minimum cardinality of instructor is 0, right? So what that means is an instructor may or may not be connected to a teaching assistant. So we can say that inside this instructor table, there probably are some instructor entries which are not connected to any of the entries in the teaching assistant table. And so we call the participation of the instructors, we call the participation of instructor entity in the help relationship as partial, okay? So instructor has partial participation in the help relationship. On the other hand, since each of the members of the teaching assistant table are definitely connected to an entry inside the instructor table, we say that the participation of the teaching assistant entity is total in this relationship, okay? Again, since each of the members of the teaching assistant table is participating in a relationship with some member in the instructor table, we say that the participation of teaching assistant entity is total in the help relationship, okay? So just remember how that works. So let's take a look at what else we have in the PDF. So I've already explained to you the set theory part. So just give this part a read in case you need to read them up by yourself. Also, I've also included some description about the different kinds of attributes that entities can have. So there really isn't really much to discuss here. There are just different kinds of attributes like composite attributes, simple valued attributes, single valued attributes, multi-valued attributes, stored attributes, derived attributes, and complex attributes. So these are very simple to understand. So what I will suggest you to do is just give this a read when I post this in your Google Classroom. And in case you have any question regarding any of these attributes, just let me know and I'll try to clear them up. So anyway, I've discussed about the properties like cardinality ratio constraint or maximum cardinality, and participation or existence constraint or minimum cardinality. Another thing that you need to learn is the degree of a relationship. So this one's pretty simple as well. Let's open up our whiteboard here again and take a look at this conduct relationship. Now, in this conduct relationship, how many entities are participating? 2 entities, right? The instructor entity and the course entity. So we can say that 2 different entities are participating in the conduct relationship, and so this relationship is binary, right? We say that a relationship is binary when 2 entities are participating in that relationship. So basically we can say that the degree of this relationship is 2. All right. Similarly, when it comes to the help relationship, Similarly, when it comes to the help relationship, we can say that there are only 2 entities which are participating in this relationship, instructor and teaching assistant. So we say that the degree of this relationship is also 2. Hence, this is also a binary relationship. All right. When we talk about the number of entities participating in this in any kind of relationship, we mean the entity sets that are participating in that relationship, not the individual entries that are actually inserted inside those entity sets. All right, so just keep that in mind. So going back to the PDF, we already talked about the ER representation. We have minimum cardinality and maximum cardinality, then followed by an actual ER diagram of the scenario that I mentioned in the slides, not in the slides, in this PDF. So just give this a read as well. And then we have a different representation of our scenarios. So here, let's go back to our representation again. All right, so let's draw the instructor entity and the course entity again, just for easier understanding. Instructor and course. Okay, and they also have their attributes. I'm just not writing down the attributes for now. And they have the conduct relationship between them. Now, we already figured out that the maximum cardinality of instructor is many in this relationship, and the maximum cardinality of course is 1 in this relationship. So we can say that many courses are conducted by let's say 1 or many instructors, right? So each instructor can conduct multiple courses, and so we can say that one instructor, that is, we can write something like this: one instructor can take multiple courses, right? So this is another way of writing down your cardinalities. Here, by writing it like this, where we write 1 on the instructor side and m on the course side, we are implying that each instructor is responsible for multiple courses, right? So this is not true in all cases. This is just what can be true for your most extreme cases, right, where each instructor may have multiple courses. So we can say that whenever we actually write down the minimum and maximum cardinalities like this, just take the maximum cardinalities on both sides and swap them, and you will have your depiction in 1 to many or many to 1 or whatever it is that you are trying to depict. So again, here the maximum cardinality of instructor was star. So what that means, an instructor can take multiple courses. And on the other hand, the maximum cardinality of course is 1, which implies that one course can be conducted by at most one instructor, right? So the restriction is placed upon course here, not upon instructor. So we can say that one instructor at a time can be responsible for multiple courses at a time, but it cannot be true the other way around. And so when you have your minimum maximum representation like this, all you have to do is take the maximum cardinalities on both sides and swap them, and then you get your 1 to many or many to many or many to 1 representation of the cardinalities. All right. So if I were to give another example, let's say I have a computer in a lab, and this computer is an entity, all right? And I have, let's say, a student entity, okay? Now, these computers are rented out to students for use. So we can say that each computer can be used by multiple students, and at the same time, each student may use multiple computers depending on which one is free at which time. So if the relationship between them is use, we can say that the minimum cardinality of student in this case is let's say 1, because at a time he may use the same computer over and over again, or he can use multiple computers in multiple renting sessions, and so his maximum cardinality is going to be many, right? And similarly, for a computer, each computer in the computer entity set can be used by the same student over and over again. So in this case, his minimum, this one's minimum cardinality is going to be 1. But it is also possible that the same computer can be used by multiple students in multiple times, and so we can say this one's maximum cardinality is also going to be many. Now, if you were to take the maximum cardinalities of both of these two entities and swap them for getting the minimum, for getting the 1 to 1, many to 1, or many to many relationship depiction, then you would get what? Many to many, right? That is, the relationship between computer and student in this case is many to many, right? So that is how you can actually figure out the relationships and cardinalities between multiple tables and multiple entities. Now going back to the lecture material, here is a representation of different types of attributes that can be used when you are actually drawing any ER diagrams. So the ER diagram that I showed you over here, this is one way you can draw ER diagrams. Another way of drawing ER diagrams is like this. Let's say you want to represent your entity like this, instructor, and you want to represent each of the attributes of the instructor individually. So you can draw something like this. Each of the circles represent one of the attributes of the instructor. So name, age, and phone, right? Similarly, for course, you can do the same thing. You will have attributes, you'll have circles for each of the individual attributes. So ID and credit. So I think those two are the only two attributes for course. Anyway, and then you have the relationship between them. All right, you can draw ER diagrams like this as well, but I generally prefer drawing it like this because in this case you can fit more information into a more smaller space. So it's up to you which representation you want to follow, but I will suggest that you follow this notation, right? There are also some other notations like crow's foot notation, which you can also look up. It's also very easy. You can follow that notation as well. Now going back to the slides, or going back to the lecture, this is simply a representation of the different kinds of attributes that you can have in an ER diagram, right? So again, just look at the different types of attributes that I have included in this lecture material and go through this diagram. And in case you don't understand anything, just let me know and I will discuss about them in the theory session or in the lab live session, all right? All right, so now that we know how ER diagrams are made and how ER diagrams are actually implied, what ER diagrams actually imply, let's use a tool to actually create an ER diagram. So for now, I have drawn them by hand, right? So there are some very specific tools that you can actually use to draw ER diagrams. So right now we are going to take a look at one such tool. All right, so the tool that we will be using is actually an online tool that you can use to basically draw ER diagrams, okay? And this tool is called Lucidchart. So simply Google Lucidchart and welcome their page, that is open their page, and you will basically be welcomed to this page, all right? So you obviously have to sign up first to use their services. So after signing up, just log in. So I'm going to log in here, give me a sec. Right, so once you log in, this is the dashboard that you're going to see whenever you enter Lucidchart. So on the left side here, you can see you have an option to create new templates or new diagrams by using templates. So just press new here and press start with a template. And in the search bar here, simply write DBMS, ER diagram, and also write UML because UML notation is the one that we want to use. And here in the search results, the first option you see here is the one that we are going to use because here you can see it has options to add or use minimum and maximum cardinality notations. And so this is the one that we want to use. You also have the option to use crow's foot notation, which you can also search and find out. But since we are going to use minimum and maximum cardinality notations, this is the template that we are going to use. So just tap on use template and wait for it to load. And after it has loaded, you can see that you get a nice template which you can use to start creating your own ER diagram, right? Now, remember the example scenario that we just discussed in our demonstration. So let's try and draw out that scenario. Let's delete the objects that we don't really need. Let's say, yeah, this object, these other objects we don't really need. So let's work with the ones that we have here, right? So let me just center this. There we go. So the first entity that we had was instructor. And the second entity that we had was course. Great. And in the instructor, we had fields like name, age, and phone. And on the courses side, we had course ID, credit. So these were the two attributes that we had in the course table. And since we don't really have this third entry here, we are going to delete this entry by using this option. And in case you need to add more entries, you simply select the entity to which you need to add more attributes and just click on below or above or anything else. Anyway, so that's how you can add attributes to your entities as well. Now, as for the relationship that we have between these two entities, well, the way you can depict relationships by using Lucidchart is a bit different than what we saw in our hand-drawn examples. So here, notice this notice this dashed line here between these two entities, and this dashed line is connected to another entity box here. Now, the way relationships are depicted here is like this. The name of the relationship was conduct, right? So we named this entity as conduct. And in case we need to add any attributes to relationships, we can do that through this field here as well, through this fields inside under this conduct entity. So basically, it is just like entities, it is possible for relationships to have attributes as well. It is not limited, that is, you are not limited to having attributes to only entities. Even relationships can have attributes. So for example, let's say you have a student entity and a school entity, and the relationship between these two entities is student goes to school, right? So we can say that the name of the relationship is goes to. So in this case, we don't really know what medium of transport the student is going to use to actually go to the school, right? So we can say that the medium of transport is an attribute of the goes to relationship, and in that case, we can add goes to as an attribute to the relationship goes to. The mode of transport is the attribute that we can add to the goes to relationship. So here we could have written something like this: transport mode, right? But in this case, we are assuming that our relationship conduct does not have any attribute, or even if we do want to consider, let's say we can say credit hour is an attribute that we want to assign to our conduct relationship, which basically defines for how long each of the instructor is actually taking a course. So anyway, this is the depiction of the ER diagram for our instructor and course example. Now let's fix the cardinalities here. So for instructor, the minimum cardinality was 1 and the maximum cardinality was many, since the instructor can take a minimum of 1 course and a maximum of many courses. But on the other hand, on the courses side, the minimum cardinality is definitely 1, but the maximum cardinality is also 1. So we are going to delete that and we are going to write 1 dot dot 1. All right, and there you go. We have our ER diagram for the instructor and course relationship. Now, instead of using this notation where we have depicted the relationship using another entity figure, you can also use the diamond shape that we have used in our hand-drawn pictures. And to use the diamond shape, we basically have to drag and drop that diamond shape from the shapes that we have here, right? Now, notice that by default, you don't really have that many shapes in your panel here. So what you have to do is you have to add shapes, right? So simply tap this button, search for UML, and tick mark this option and select use selected shapes. Now you see that you have a plethora of options to choose from, and just scroll down to the bottom and you see that you have the relationship diamond here again, right? So instead of using this figure here, this conduct entity here, you can simply use this relationship diamond shape to define the relationship between this instructor and course. So here the name of our relationship is conduct, and since we had added an attribute to this conduct relationship, we are going to use this attribute circle here, and the name of the attribute was credit hour, right? All right, great. So now we have perfectly drawn that shape again, and also our minimum and maximum cardinality notations disappear. So let's bring them back. Just type text in the search bar here and go to your UML UML widgets, I guess. Yeah. So go to your UML class diagram here, drag this and drop it here. Just simply write one dot dot star for your instructor, and for your course you do the same thing. This is just going to be one dot dot one, and there you go. You have your ERD diagram for the instructor course example that we just saw a bit earlier. So remember, I am no expert in using the Lucidchart application, so there are a lot of other things that you can do and a lot of more efficient ways you can actually draw ER diagrams, and that is for you to figure out as part of your lab task. So in your lab task this week, you are basically going to be given a couple of scenarios, and you have to draw the ER diagrams for those scenarios using this Lucidchart application. All right, so get a hang of the Lucidchart application by actually implementing those scenarios and drawing ER diagrams, and this will become much more clear to you. All right, so coming back to the lecture slide, let's recap what topics we discussed today. So we took a look at entity and entity sets. Remember, entity sets are generic representations of entities, and entities are instances of entity sets. Then for attributes, I've already told you that there are different kinds of attributes like composite, simple, single-valued, multi-valued, stored, derived, and complex. Just give them a read, and you will be able to understand all of those by yourselves. And then we talked about relationship and the different properties of relationship, like the degree of a relationship, the cardinality constraints, and so on. And then we took an example scenario and tried to draw an ER diagram for that scenario. And finally, we also talked about the different the representation of different types of attributes. Also, we talked about Lucidchart, which is a tool that you can use to draw ER diagrams online. So basically, you're going to have to learn to use that tool, or you are going to learn to use that tool in this lab. Okay, so anyway, that's it for this lab demonstration. If you have any question, let me know in the live session, and I will see you later. Take care.